Hi everyone, my name is 𝗏𝗏𝗃𝗃. I'm a developer advocate here at Timescale. And for Timescale Tuesday this week, we're going to continue in our series about creating sample data. Now we're technically in the third part. This is going to be a number of parts over the next month or two. Last time I looked at generate series as a really nice and convenient way to create sample data for things like time series specifically when you're using a tool like Timescale. As I was doing that video, as I was preparing for it, I realized there's so many other neat things you could do to create new and more realistic samples of data that might help you better understand your specific system. So this is a part two, a second part to generate series as we look through many ways to create sample data for evaluating and using tools like Timescale. So let's go ahead and get right to SQL. That in these things seems to be the most fun to me. And so I'd like to show you where we're at and continue forward. So I've been using 𝗥𝗏𝗃𝗏𝗃. That is the tool I'm currently using. I'm not using a terminal with something like pSQL. It's just a little bit easier for me to highlight things on the screen and show you what's going on. So we ended the last video with this query, and we saw that this got us a little bit closer to realistic data as far as the values go. We looked at how you can use something like this random, what we call a high-low calculation. And this at least allows us to say, hey, I want CPU to be between these two numbers, not just a random, very small number with 13 decimal points, something that maybe seems more realistic. So if I want to demonstrate this to someone or see kind of what the values look like, they're at least in reasonable ranges. And so this worked. I'm just going to do a select on the statement. Now, again, remember, with generate series, there's two primary things you need to remember with this. One is that even though I'm connected to Postgres, the database, is what's providing the value back to me, but it's not selecting any data from a table, right? It's generating it on the fly, which is what makes it so convenient. I can test stuff out without inserting lots and lots of data and seeing if I'm right and then redoing it all. I can play really quickly. We talked about that last time. And we also talked about how generate series, when you essentially select from multiple tables in Postgres without a join, you end up with this Cartesian product of both tables. So in this sample, I'm generating 1,000 rows, so 1,000 IDs, and I'm multiplying that by however many rows come out of this. It's a reading every minute for 1 day, so that's 1,440 readings. When you multiply these two things together, I should end up with approximately 1.4 million rows. And so if I run that, we see that we get a value. Now in 𝗥𝗏𝗃𝗏𝗃, I'm only seeing the first 200. It does that for me automatically. But if I were to insert this, I'd get 1.4 million rows. And we at least see that the values start to be a little bit more realistic. I have CPU between those two boundaries to a couple of decimal points. It's not lots and lots of decimal points. So this is beneficial. Now, I wanted to talk about this formula. So the way this formula works is we basically are giving it a high and a low value. And because it's being multiplied by random, order of operations, random is going to produce a number between 0 and 1. It's then going to multiply it by whatever the value of this subtraction is, right? So the high value minus the low value. And then we're going to add the minimum value back. And the reason for that is if random generates a value that's essentially 0, that product will be 0. So I will at least end up with the minimum value every time. If that product ends up being 1, at a bare minimum, I'll get the max minus min plus min. So I'll be back to the maximum number if random were to generate a value of 1. So you'll always end up between this range. The problem is that gets really tedious to type every time when you want to round it and you want other things. And we talked about all that last week. So let's look at a more realistic example. So now that we can create some values that are somewhat realistic, how could we do this in a more repeatable way that's honestly just easier to do? So if I were to create this table, which I've already done, and I have, maybe I'm measuring the path of my truck fleet. I'm a carrier, and I want to track some information about it. And I want to generate data that looks similar to what I might be tracking, right? I have latitude, longitude, and temperature and distance. I even have a place for a textual note here. Maybe sometimes there's a note about a condition on the truck, and most of the time there's not. And sometimes it's a very long note, and sometimes it's just a few characters, right? So to create fake data that at least looks more realistic, I want to be able to do it more effectively, quite honestly. Now, I could do a query like this. There's a couple things here that just really frustrate me, at least, if I had to type this out every time. One is, I don't want to type this every single time round with random and get my numbers and cast it to numeric. And it just is a lot to do. And it's not very repeatable. There's a lot of opportunity for mistake here. So we want to do something that's repeatable, and that's where SQL functions come in. The second thing is getting a random text value of length turns out to not be very easy in a form like this. We'd have to go through a lot more work. So that is the formula I shared last week for coming up with random text of variable lengths. It just isn't very useful. It doesn't work as I would expect here. So I'm going to produce some data. This query does work. I'm just selecting data as if I were going to insert it into a table. And you'll see that I get at least realistic values. This Latin ln is actually values within the state of Pennsylvania. That's where I'm located. Now, if I were to take minute to minute for one truck, the truck might be bouncing all over the state, but at least it's contained within the state. So that was good. The temperature range is realistic. Maybe the distance traveled in miles is somewhat realistic. Weight, it's carrying a load that's shifting over time. Now the text ends up being harder to do in a random fashion this way. And that's because of how the function is called with this CTE being selected in. So there's a lot more work to do. And honestly, this is just hard to type and hard to keep up. So what I chose to do instead is create a couple of functions. So these are Postgres functions that allow me to do repeatable work. And what I did is created one for numeric values called random between. It gives me, I just provide a low number and high number, and it gives me a random value back between those two numbers. And then I can round it or not round it. So I can either get essentially an integer back, or I can get a double precision value back. And I set a default to round to 0, so that will give me an integer back if I don't provide that value. But if I do provide it, it will go ahead and provide that rounded value back. So with this function in place, you'll see that it becomes much easier to produce those highs and lows. And then I did something similar for the text. Now the text one, I wanted to get a little bit more creative. So there's also a low and a high value. And that just means give me a random length of text that's at least as much as the low value, so 1, or no greater than the high value. The defaults here are 1 and 50, but I can pass anything I want to that other high end. So I can get a text of 250 characters, for instance. And so the other thing I do to make it slightly more realistic is once I create that random value, so this is the length of text I'm going to create, I go ahead and divide it. I basically say, hey, if the remainder dividing by 5 is greater than 1, in that case, go ahead and give me that random integer. But for some reason, it's 0 or 1, so it's equally divisible by 5, or I just have a remainder of 1, don't give me any text back. I wanted some opportunity to not have text be returned. So now I have these two functions, and I can create a lot more realistic data for this truck log. Now you see that it's honestly just easier to read, right? This is a very simple function that I can create. All of this is happening. Once again, all of this is happening, and I'm going to comment out that insert for a second, without me actually inserting any data yet. I can test all this out. I can see, what if I do 1,000 trucks and they report every 10 minutes? What if I do 500 trucks that report 1 minute? I can see the amount and volume of data I'm going to get. So let me run the select statement using those new functions I created. And you'll see that this data really starts to pop a little bit more. It would allow me to more reasonably demonstrate both scale and maybe some values for the application I'm writing. Right, I have those same values and decimal points as we talked about. The Latin ln are also still within the state of Pennsylvania. And then the text, hopefully you can see this. I have a lot of random lengths. So it's between, I chose between 1 and 128 characters. Sometimes I get no text back. I could enhance or maybe create another function that would return JSON data. So if your application uses a lot of JSON and you have maybe a JSON-B column in your Postgres table, you could actually randomly create JSON data. Maybe that's something I'll do in a future video. So a lot of opportunity to provide something more realistic without a lot of work. Once I have those functions, creating these columns of data took me a minute. And we know that generating that series really can happen very quickly and allows me to get the kind of data that I need to create something that's more realistic for you to play with. So I hope this was helpful. Please subscribe, like this video if things like this are interesting to you to play around with. These are the kinds of things I hope to do more of. We're going to try and start a live YouTube or Twitch channel here in the next few weeks. Maybe once a week, just to show you fun things we're learning as we're using Postgres, as we're using Timescale, as we're trying to help our clients, and as we are examining all the new features that are coming out with TimescaleDB. Please subscribe to this channel again, visit us on Slack, and Docs is about to have some really neat changes coming to it. So please go continue to look at our Docs, suggest changes if you see something that we could add or make better. And please just come join the team. We are excited for everything that's happening at Timescale, and we're really looking forward to how we can help you. Have a great day. Take care.